The next set of tutorials on this channel will cover the different areas of the model, namely photovoltaic panels, solar thermal panels, small wind turbine, passive solar design, passive solar ventilation, movement of the louvers, LED lighting, water pumps, rainwater tanks, green roof, heat sinks, clerestory, and other.
This is the sustainable architecture model which we're going to use to explain some of the components and areas of sustainable architectural design. Quickly, just an overview of the model. We have the photovoltaic panel right there. We have a green roof. We have louvers, and I will demonstrate how they work later. We have a small wind turbine. We have an additional louver to the east or the west of the building. We have a some LED lights on the inside which you can't see. I'll show that later. We have a strip light with tiny little LEDs. We have water tanks where we harvest the water which runs from this building down and into the water tanks which will be reused. White water and grey water. White water meaning filtered, which we could use for drinking, and grey water which could be used in the gardens and so on. We have a green roof. We have a solar thermal panel at the back here which I will show now. And
this model is controlled with a transmitter.
The sustainable model which we will use to explain sustainable features and functions in sustainable architecture is based on remote control aircraft equipment. The transmitter over here, in a very simple terms, sends a signal or communicates with this jet or Stryker, a foamy made out of foam. It runs on 11.1 LiPo battery. Some electronics in here. It's just an electronic speed controller, and at the bottom right there at the back sits a receiver. So the small receiver is the communication or the telephone line between the transmitter and the receiver. We have the propeller at the back, the rudders right there, and the ailerons in right over there. Now we're going to quickly switch it on and illustrate how it works. We're going to power up the Stryker jet now. First, switch on the transmitter. Second thing we do is we connect the battery to the jet. You can hear the jet communicate with the transmitter. It's a 11.1 volt battery that gets strapped in there like so. Push the wires in, make sure everything is under the cover, put the cover over. So what we have is, we have the plane right there. We can see the function of the servos. There's one of the servos are in the wing right there. It's just a small little square box with an arm on it, and when I move this joystick here, or the stick, like so, left and right, it would just push the aileron up and down in this instance. That one works the rudder, as you can see. There you are. So this stick controls the propeller at the back, so we're just going to give it a full throttle quickly. So this stick controls the throttle, the rudder, and the aileron. Up, down, a left roll, a right roll. So it's up, down, left and right roll for the jet. We're going to use the functions of the servos to illustrate how a model for sustainable architecture could work. For instance, how it powers the louvers and so on. This model communicates with a transmitter, a typical remote control transmitter used for model aircraft. The transmitter would move the louvers. We've powered the house. The receiver is communicating with the transmitter. So the first thing I'd like to show is the louver on the clerestory moves up and down. So the sun sits higher in the sky during summer and lower in winter. So if I lift it up, the sun, which sits over here somewhere, would shine through the window and heat up the stack. However, during winter, the louver would move down, and as the sun sits higher in the sky now, we can adjust the angle so that it would screen out the sun and keep the building cool. The other alternative or option is where the lower louver can also move up and down, and again it will be up during winter so that the sun can get into the building, but lower during summer to screen the sun from the building. So we don't want the sun to shine into the building and heat up the building, because we want it to be cool during summer. The third option, I'm going to flick the switch here, and that would open the roof. We can use this option or this function for passive ventilation. In other words, the warm stale air would escape. We could program all of this electronically so that once it reaches a certain temperature inside the house, or the air gets stale, it would just open quickly and close again and release that stale air. Now the ideal would be to have some vents at the bottom here, an opening right there. So once you open the clerestory and the warm air escapes, cool air and fresh air would enter the building through the vents. That is a simple principle of passive ventilation. You can see some openings over there, specially provided for passive ventilation over there.
The new model evolved from this older model, and you can just see it's a simple timber structure with a pitch roof right there, some walls made out of timber, a solar panel, a battery inverter, some switches, a buzzer, and some more. A different angle of the old model. Additionally, you can see a strobe, the buzzer, some switches to do tests with, and an LED light. The next couple of images shows the construction of the new model to illustrate sustainable architecture. The next set of tutorials on this channel will cover the different areas of the model in depth, namely photovoltaic panels, solar thermal panels, small wind turbine, passive solar design, passive solar ventilation, movement of louvers, LED lighting, water pumps, rainwater tanks, green roof, heat sinks, clerestory, and more.